Today I will show you how the resistance changes when 1, 2, and 3 heating elements are connected in parallel. 3 physical heating elements. This is how to connect and take measurement of one heating element resistance. The measured value of this one heating element is 67 ohms. Circuit diagram of 2 same heating elements in parallel. The calculated value using the stated formula eventually is 67 divided by 2, and the result is 33.5 ohms. This shows a decrease in resistance as the number of elements increases. When the elements are 3 in parallel, the combined resistance using the stated formula is eventually 67 divided by 3, and the result is 22.33 ohms. A further decrease in resistance compared with 2 elements. So as the number of elements increases, the combined resistance falls. However, when power is applied, the current taken by the 3 elements further increases. Let's test the element practically. Okay, so now let us take the resistance reading of this one heating element. The first thing to do is to set this multimeter on ohm, put it on the list ohms, as you can see. If it fails to read, it means the value you've set on the instrument ohms range is less compared to the resistance of the heating element. So what we do is we increase it to the next until we get the right reading. Okay, so here I want to increase it from this 0 value to 200. Okay, and test. Okay, so one of our probe is already connected to one leg of the heating element. The second probe is coming to the first terminal. Okay, so here we have 68 until it gets stable. All right. Okay. All right. Okay. 67.3 will take 67 approximately as the value of the resistance of this heating element. All right. All right. This time around, let us take the combined resistance of these 2 same elements, 67, 67, 2 of them connected in parallel. Here, assuming here is the beginning, this is the end, all the beginnings are joined together. This and this. All the ends are joined together. All right. Now, one of our probe is on this end, while the other one is on this, first, terminal. Here, we are getting 34, 33, approximately 0.5, ohms as the combined resistance, which our formula also proved to us. All right. So this is when the 2, elements, each of 67 ohms, are connected in parallel. It is simply to divide the resistance of each 67 by 2, and you have 33.5 as the resistance of the 2 of them combined. So here we want to measure the resistance of these 3 heating elements connected in parallel. All right, each of 67 ohms. Our instrument, is still set at 200 ohms. Okay, so I have done the connection, but let me explain what I have done here. Now, if here is terminal 1 and terminal 2 of the heating element, I have joined all the terminal 1s together, as you can see here, together. Then all the terminals 2 together. All right, then together. Okay, now one lead of our instrument is connected to the second terminal of the third heating element, as you can see it here. And The other leg, I want to connect it to the first terminal of the first heating element. And so you can see the reading. Our calculated value is 22.3, but here is what the instrument is giving to us, 22.6, 22.5, which is not far from the calculated value. All right. What happened is the resistance of 67, when three of them are combined like this, connected in parallel, it is to divide the 67 by 3, and then we will have 22.3 as the calculated value. All right, here is giving us 22.5, which is not too bad from the calculated value. So this is how we take resistances of a heating element and even other loads. All right, so that is it. So if you love the video, share it with your friends, give us your comment, and subscribe for more videos. Thanks for watching.